Welcome to Brain Vision.
We need to find the forces exerted at the point D and the point F whenever this rail is lifted by the tongs. So we have three different free body diagrams to represent the different points on the machine. So we have a free body diagram for the rail, a diagram for the A junction, and also a diagram for the BDF tong. So to start solving this problem, we're going to first find our weight W of the rail. And we're given the length of the rail and also its unit weight. So to find the weight W, W is going to be equal to 39 times 44, and that'll give us a weight of 16 pounds. So now that we have the weight, we can now take the moment about this point E on this free body diagram. So we can say that the sum of moments about the point E is equal to 0, and the formula for that is going to be negative W times 0.8 plus F of Y, the Y component at the point F of the force, times 1.6 equal to 0. And solving this for F of Y and plugging in W, we get F of Y is equal to 16 times 0.8 divided by 1.6, and this will give us a force of 858 pounds. So next we're going to calculate an angle theta. So we're going to calculate angle theta from this free body diagram, and this angle theta also appears on the tong free body diagram. So we can solve for that angle theta by taking the tangent inverse of 6 over 9.6, and this will give us an angle of 32 degrees. So we can now say that using the free body diagram in the middle, we can say that the sum of all forces in the x direction is equal to 0. So we have that sum of all forces in the x direction is equal to 0, which in terms of that free body diagram, we can write as force of AC times the cosine of theta minus the force AB times the cosine of theta is equal to 0. And from this equation, we can rewrite this equation as F of AC is equal to F of AB. And next using the same free body diagram, we're now going to say that sum of all forces in the y direction is equal to 0, which we can write as W minus the force AC times the sine of theta minus the force AB times the sine of theta is equal to 0. So we can substitute the known terms and solve for the unknown f of AB. Since in this equation we can replace the f of AC with f of AB from the previous expression. So after plugging in the known terms, we get 1716 minus f of AB times 2 times the sine of 32 degrees is equal to 0. And solving for the unknown f of AB, we get a force that is equal to 19.1 pounds. So we're now going to go back to our free body diagrams. We're going to look at this free body diagram of the tong, and we're going to take the sum of moments about the point D. So we can now say that the sum of moments about the point D is equal to 0. And we can write this as the force F of x times 8 minus the force AB times the cosine of theta times 12 minus F of AB times the sine of theta times 9.6 minus F of y times 0.8 is equal to 0. So we plug in the known terms and we solve for the unknown variable f of x. So we can rewrite this equation as f of x times 8 minus 19.1 times the cosine of 32 times 12 minus 19.1 times the sine of 32 times 9.6 plus 858 times 0.8 is equal to 0. And solving this equation for f of x, we'll get a force of 3,175 pounds. So next what we'll do is we'll take the sum of forces, in the x direction and set it equal to 0. And using the third free body diagram, still using this free body diagram of the tong, we can write that as d of x plus f of x plus f of ab times the cosine of theta is equal to 0. And plugging in the known terms, we can write this as d of x is equal to negative 3175 minus 1619.1 times the cosine of theta. Cosine of 32, since we already know what theta is. So cosine of 32. And this will give us a force of negative 4,548 pounds. And next we're going to solve for sum of all forces in the y direction and set that equal to 0. And we can write this as negative f of y plus d of y plus f of ab times the sine of theta is equal to 0. And solving for d of y and plugging in the known terms, we get that d of y is equal to 858 minus 1619.1 times the sine of 32, and this will give us a value of 0. So since there's no y component in the force at the point D, we can conclude that the force at the point D is going to be equal to just the x component. So force D is going to be equal to 4,548 pounds in the left direction. And solve for the force at the point F. At the point F, we've already calculated the x component and also the y component of the force. So we can find the magnitude of the force and use trigonometry to find the direction of that force. So for the last step, we can write that the force F that's going to be equal to the square root of its components added together squared. So 3175 squared plus 858 squared. And this will give us a force of 3,288.9 pounds. And to find the direction of this force, we take the tangent inverse of 858 divided by 3,175. And this will give us an angle of 15.12 degrees. So for our final answer, we can say that the force at point F is equal to 3,288.99 pounds. And it's going to be going in a direction downward at an angle of 15.12 degrees.